For question 23, it talks about the displacement x meters of a particle moving along a straight line after t seconds is given by t cubed over 3 minus 3t squared plus 9. So this one is application of calculus in kinematics, that is application of calculus. Now, they want us to determine the value of t when the particle is momentarily at rest. That means the particle is not moving. So when no particle is moving, the velocity equals to 0. When a particle is at rest, the velocity of that particular particle is 0, that is meters per second. So when it is momentarily at rest, for us to find velocity, we are going to differentiate displacement. We know that we normally come from displacement to velocity, then to acceleration. So you differentiate as you move that. So for us to get velocity, we do differentiate displacement. For us to get acceleration, we differentiate velocity. So we are going to differentiate our displacement. So velocity is going to be dx, that against t, with respect to t. So it's going to be a differentiation of this one is going to give us t squared minus 6t. If you differentiate 9, that is a constant, it becomes 0. And this one equals to velocity, which is equals to 0, because at rest the velocity is 0. So factor out t, and you remain with t minus 6 equals to 0. So it means that either t equals to 0 seconds or t minus 6 equals to 0. So the value of t equals to 6 seconds if you move t to the other end. So the particle is momentarily at rest at t equals to 0 second and at t equals to 6 seconds. Part B, it wants us to find the values of the displacement x meters by the time the particle comes to rest. That is, by the time the particle comes to rest. Then you ask yourself, when is the particle at rest? The particle is at rest when t equals to 0 and when t equals to 6 seconds. So at t equals to 0, we have this equation for displacement. So it means that the value of x equals to t cubed, that is 0 cubed over 3 minus 3 0 squared plus 9. All this one simplifies to 0 and this one remains 9 meters. Then next, at t equals to 6, that is at t equals to 6, then the value of x equals to 6 cubed over 3 minus 3 into bracket 6 squared, then plus 9. So at this particular place you have that take 6 cubed divided by 3, then minus 3 into bracket 6 squared, then plus 9. All this one you can put in your calculator and you get that if you take 6, you cube it, then you divide it with 3, then you subtract 3 times 36, then you add 9 to it, you end up with negative 27 meters. That is the value of the displacement when the particle comes to rest. Now, you want us to determine the value of t when the velocity of the particle is negative 5 meters per second. Now, what is our velocity from up here? Our velocity is t squared minus 6t. So it means that t squared minus 6t equals to negative 5. So bring negative 5 to the left hand side and have that t squared minus 6t plus 5 equals to 0. So this one is a quadratic equation that we can solve by factorization. So when you factorize this one, you will have t minus 1, then t minus 5 equals to 0. We can look more on factorization. How do we factorize? So it means that either t minus 1 equals to 0, so t equals to 1 second, or t minus 5 equals to 0, so t equals to 5 seconds. T equals to 0 or t equals to 5 seconds. But C requires us to determine the acceleration of the particle at t equals to 2 seconds. Now remember what I said, for us to get acceleration, we do differentiate what? We differentiate velocity. So the statement for velocity is t squared minus 6t. So if you differentiate the statement for velocity, you get acceleration. Acceleration equals to dv with respect to t. So if you differentiate that one, you will end up with 2t minus 6. So at t equals to 2, it means that this one will be 2 into bracket 2, then minus 6, and this one gives us negative 2 meters per square second. That is the acceleration for that particular particle.